Hey, what's up, guys? This is Chung here. So today, let's take a look at today's daily challenge problem, number 213, house robber number two. Um, I think it's a classic problem. If you guys have done the house robber number one, so this one is a little bit extension for the other one. So the basic idea is this. So you're given like a list of numbers, right, which represents a house, right? So each number represents the value of each house. And you are a professional robber, okay? And you cannot rob two consecutive houses. So which means that if uh, there are like four houses here, right? So if you rob the first one, right, and then you cannot rob the second one. You have to skip one and then rob the third one because if you rob two consecutive houses together, you will trigger an alert. So, and the police will get you. Okay. So the purpose of this problem, the house robber problem, is that what it asks you to calculate the maximum amount of money you can rob without alerting the police. Okay. So that's basically the idea. And for the house robber number one, it's just this list. Okay. That's that. But for this one, the house robber number two here, so the only difference here is that, there's a like so all the houses at this place are arranged in a circle. So which means that the first one and the last one are treated as neighbors, right? So which means that in house in house robber problem number one, you can rob two, and you can also this one. You can rob the first one and the last one together because they're not treated as a neighbor. But for this one, like basically you cannot rob the first one and the last one together. That's the only difference. Okay. And I think at the beginning, at the first glance, this problem seems a little bit tricky to solve, But if you think it a little bit more, actually, you can just separate this problem into two cases. Okay. Like I said, the first case is that we rob the first house. Okay. And if we rob the first house, so which means that we cannot rob the last one. Okay, so as if we're robbing from the first one to the n minus one, right? So that's the first case. And the second case is that we don't rob. We don't rob the first one, which means that we can rob the last one, right? So that's the only two cases. So I mean, the easiest way of this problem is going to be we just do a two pass, right? So we loop through. Basically, we use the similar logic as the house rob number one, but the only difference that we have like two cases. So the first one is we rob the first one, so which means we cannot rob the last one, or we don't rob the first one, but then which means we can rob the last one, and then we just get the maximum out of those two passes. Okay, cool. So, and I'm going to just write the no-brainer solutions. Of course, you can improve that into a O1 space, right? So basically, the no-brainer, the most naive solution is like this, right? So basically, we have a DP with a range of n, okay, with a length of n here, and then we just do a loop through here. So like I said, so the first one, okay, let's do the first one. First one is we rob. Let's say we rob first house, right? So which means what is that? So okay, by the way, so DP represents the maximum amount we can rob up to this number of house. So which means if we rob the first one, the DP0 is obviously equal to this one. Okay. So and yeah, so if I only write the solutions for the house robber number one, it will be something like this. Basically, we have a rob rob the current one, so which means that if we rob the current one, it's going to be numbers I plus dp I minus 2, right? So because if we rob the current one, we cannot rob I minus one. We need to rob I minus two. But since we have a like a index range here, so we just do a simple check here. Basically, if I is equal greater than 2, then we do a DP else 0, right? So that's pretty straightforward. And then we have a not rob, right? So not rob is simply do a DP I minus 1. Because since we're starting from 1 here, we can just do a DP I minus 1 here. And then in the end, we just do a DP I equals to a max of the rob and not rob, okay? And then we return the DP n minus 1. Right, so that's the template. That's how we do it without this restriction here, right? Without this circle house restriction. So but in this case, like I said, because as you guys can see here, for the rob the if we rob if we rob the first one, which means whenever we are at the last house, there's no more this option anymore. So for the last one, we have to do this, right? So we can simply do this, right? So I mean, so now since we robbed the first one, right? And then here, think I'm I'm pretty sure there are like other more elegant way of doing this, but I'm just using like a dumb way, basically. If I uh, is not the right, so basically if the I does not equal to the last one, we can do uh, we can do this. Then we do this, right? I mean, then else, right? So else means we're at the last one. We're at the last house, which means that we have to do this. We just do a I minus one because for this case, for if we are at the last house, we cannot rob it, right? So we have to use this. Okay. And yeah, and that's that. So now we just do a rob. We rob first, right? Rob first equals to DP n minus 1. Okay, so that's the rob of the first house, right? So we can just copy here. We copy everything here, right? I mean, same thing here. So here we don't not drop the first one. Sorry, sorry about my Chinese input here. So we don't rob the first one, which means the first one is 0. We can skip that. So if we don't rob the first one, so this thing will become the regular rob house, right? So we can just do this rob house solution here. Okay, that's basically the not rob the first one. So in that case, I mean we have for each of the house, even for the last one, they're all having the two options here. So we can just use the rob house number one solutions to handle this case, right? So now we have a not rob first also equals this. So in the end, we simply return the max of the rob first and not rob first. Okay. Yeah, I think, yeah, that's that. Run the code. All right, accepted, submit. Cool. So it's accepted. I mean, of course, the time complexity is like it's 2 O of n is actually O of n, right? So that's the time complexity. And space complexity, it's for this one it's O of n, but as you guys can see, since the each state, right? So for each state, we're only depending on 1 and 2, right? 1, 2, or maybe 3, or sorry, not this one, just 1 and 2 here. We can easily get rid of this like DP array here, and we can just use two variables to to represent, right? To change this space complexity from O of n to O of 1. Um, I'm not going to do that here. I mean, I'll just leave that to you guys to basically to repeatedly like set these numbers. Um, you know what? Okay, you know what? I'll do it anyway here. So just for those who are interested in this, let's see here. Okay, and here's how we do it, right? So basically now we can get rid of this DP here. Okay, and we just need two variables here. Excuse me, sorry. So I'm gonna define like two variables, so pre1 and pre2. Okay, and pre2 here. Also a current max maybe. So so the pre1 is the dpi minus 1. Okay, so this one is the dpi minus 1, dpi minus 1, and the pre2 is basically it's the dp I minus 2. Okay, so I'm just doing it in the most naive way here. Basically, I'm just going to copy and paste here. So at the beginning, right? So if we rob the first one, so the pre one is going to be the nums 0, right? Because the since we're starting from 1 here, so which means the pre one, the dpi minus 1 is the current is the first house value, right? So here I'm going to have like this dp plus pre2, right? So we're going to simply ignore this one. And then, uh, so this is going to be the pre1, right? And then here we have I'm going to use a current max. Okay, so this is the current max. Current max equals to that, or the current max equals to this pre1. Okay, so that's that. But since we're reusing all those variables, don't forget to reassign those variables. So now the previous after this loop, right? So the previous two will become the previous one, right? And the current max will become to the previous one. Okay, right? So and in the end, we simply return the previous one here. You know, so we don't return the current max here because the in the case of there's only one element here, right? So the previous one will store the initial number here. That's why we use previous one here. Okay, so yeah, so that's that. I mean, we can just copy everything here, right? So now t here is we do not rob the first house, which means the first one is 0, right? And here it's same thing, right? So we have I'm going to copy this part here, so, okay, and also this part as well, right here, and same thing here. Okay, yeah, I think that's it. Run the code. Okay, accept it. Cool. So it's also accepted, right? So that's how we basically how do we compress the space complexity from O of n to O of 1. I mean, I know this is like a kind of ugly code since I have a lot of duplicated codes here, right? I mean, I think you can even encapsulate this part into some like helper functions. But anyway, I'm just showing you guys the the general idea, right, of solving this kind of problem. Basically, we just um, separate them into two easy case, right? So and then the first one is rob the first house. So for that, we cannot rob the last one. That that's how I handle it, right? Basically, I have another if else case here to handle that. And if we don't rob the first one, then the problem will exactly be the same as the rob house problem number one. And then we just get the maximum from those two scenarios. Cool. I think that's it for this problem. Yeah, thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.